surface area. So first thing you want to identify is which axis you're revolving around. So here is a typical kind of problem you see on a homework quiz test. So it says revolve about the x-axis. So the first thing you want to say is I know that the radius will be y because I'm revolving around the x-axis, right? Taking a curve, spinning it around. So the radius is going to be this distance right here, and that's y. Okay, that's the first thing. The second thing you want to identify is how the information is given to you. Looks like I'm going to do the integration in x. So I want to use dx. So you know surface area is 2 pi r, r, right, r for radius, times the arc length. And the arc length is the what we did before, 1 plus the derivative squared, dx. Okay, so now here's where we start filling things in. So surface area is 2 pi. Since I have dx integration, for the r, for the radius, where I want to plug in y, right, I'll just kind of go slow here, I can't use y inside of dx integration. So I'm going to replace y with this. So I get square root of 4 minus x squared, and then integral with the arc length thing, dx. So in here, I need to do the 1 plus of the derivative squared. And you were doing that with arc length. Okay, so I'm going to let you do the rest of that, because setting it up is the big deal. This one again, so here is a typical problem you'd see. So it says revolve about the x-axis. So right away, first thing you want to identify is the radius is y. Okay, look at the information given. It's given to you in terms of y. So the second thing I want you to do is to say, okay, I know I need to use dy. Okay, so you start thinking, surface area. Surface area is 2 pi radius times the arc length, and we're going to use dy. Okay, so looking back at the radius, so the radius is y. I want to do dy integration, so I just leave y there. And since I'm using dy, this arc length thing has to be 1 plus g prime of y squared, and then it'll all be y's. Okay, so now we go to surface area when we're revolving around the y-axis. So let's think about it. If I'm taking this curve, spinning it around, so I'm looking at like painting the outside of this vase. So the radius is this x value. So the radius is x. So that's the first thing you need to identify. The next thing, you look at the problem, and it looks like I want to use dx integration. So I know surface area will be 2 pi radius times the arc length, and I know I'm using dx. And so 2 pi, oh, look at that. My radius is x, and I'm doing x integration, so I just put x in there, and then I do 1 plus the derivative squared dx. Okay, so then this next one, same thing, revolving around the y-axis. So first thing, identify that radius is x. Looking at the problem, and this is usually like the big thing, second thing I want to identify is I want to use dy. Okay, so surface area is 2 pi radius, arc length dy, and so my radius is x. Can't keep an x in there, so I replace x with what it's equal to. So 2 pi root y, and then I'm going to take the derivative, so g prime of y, square it times dy. All right, hopefully that helps to know what to do when.